Bismillahirrahmanirrahim. Assalamu alaikum students. Today we will discuss another topic. Let me write the heading first. Some expressions involving del. This is today's topic. Under this heading, we will discuss certain ideas. So listen patiently and keenly. In the last lecture, we discussed the idea of directional derivative, and we discussed how to calculate directional derivative in a given direction at a given point of some scalar field phi, and that involved the idea of gradient of a function which itself is a vector. So let us proceed now in today's lecture. Now if we write del phi as I cap dou by dou x plus j cap dou by dou y plus k cap dou by dou z phi. Remember, dou by dou x is partial derivative symbol with respect to x. Dou by dou y is partial derivative symbol with respect to y. And dou by dou z is the symbol for partial differentiation with respect to z coordinate. I cap is the unit vector along positive x direction. J cap is the unit vector along positive y direction. And k cap is the positive unit vector along positive z direction. Now, when we write Delphi as this, then this bracket, whatever is in this bracket, it is del. So by itself, this del has no meaning, just as d by dx. Alone, d by dx has no meaning. We must put some function after it to be differentiated. However, it is useful to use del much as we use d by dx to indicate a certain operation. So this del indicates a certain operation on the function which we write to the right of it, right in front of it. Likewise, when we write some function here, then d by dx operates on that and we get some other function. So we call this del a vector operator because it is vector-like. So it is a vector operator. So we write del is equal to whatever is in this bracket, that is I cap dou by dou x plus j cap dou by dou y plus k cap dou by dou z, right? That's more complicated than d by dx because d by dx is a scalar operator. A scalar operator. But del has vector properties too. So it is complicated than d by dx, right? Now, suppose v x, y, z is a vector function, that is the three components vx, vy, vz of v are functions of x, y, and z. So we can write this vector function v x, y, z as I cap vx, function of x, y, z, plus j cap vy, function of x, y, z, plus k cap vz, function of x, y, and z, right? So physically, this v represents a vector field. For example, it could be the electric field about a point charge. Now at each point of space, there is a vector v, but the magnitude of and direction of v may vary from point to point. Now we can form two useful combinations of del and v, right? Remember, this is our del and this is some vector field. Now I am saying we can form two useful combinations of del and v. The first thing, we define the divergence of v. We define the divergence of v. We denote it divergence of v or del dot v. It is the dot product of del with v. So making use of the equation 1, which gives us del, we can write divergence of v as del dot v, which is divergence of v is simply dou by dou x bx plus dou by dou y by plus dou by dou z vz. This is one combination formed by combining del and vector field v. I name it 2. So divergence of v is dou by dou x of vx plus dou by dou y of vy plus dou by dou z of vz. Just like we write a dot b, if we have two vectors, then we write a dot b as ax bx plus ay by plus az bz. Here what we do the same thing, but remember that dou by dou x should operate on something. So you cannot write it vx dou by dou x. Here you can write ax bx or bx ax, that is one and the same thing. But this is how we define divergence of a vector field. Now another combination we define the curl of v. How we write it? We write curl of v as del cross V, which is curl of V. We can see, we write it just like a cross product between two vectors. So we write it in the determinant form, I cap, j cap, k cap, then dou by dou x, dou by dou y, dou by dou z. Then we write the components of vector field, vx, vy, vz. It's just like cross product. You write A cross P as determinant of ijk, ax, bx, sorry, ax, ay, az, bx, by, bz. Similarly, we define this curve of V as cross product of del with V and write it in determinant form this way. This is how we define curl of a vector field. I name it as equation 3, right? Now, as is evident, we are using del as almost a vector. Now, del phi, that is gradient of phi, as we defined it, grad phi is I cap dou by dou x of phi plus j cap dou by dou y of phi plus k cap dou by dou z of phi. This is how we define gradient of phi, which itself is a vector, right? So it's a vector function. Let me use another color. Gradient of phi is a vector function, right? So we can let vector field V in the above equations equal to grad phi, right? So if we do that, what we find, del dot del phi, that is divergence of gradient of phi. So I write it divergence of grad phi, right? So how we define it, we write it this way. Divergence of grad phi, it becomes, we write it del square phi. It is divergence of grad phi. This is simply what? Dou by dou x, dou phi by dou x, plus dou by dou y, dou phi by dou y, plus dou by dou z, dou phi by dou z, which I can write this way. I will use another color, which is simply dou 2 phi by dou x2 plus dou 2 phi by dou y2 plus dou 2 phi by dou z2. So I encirculate this, my another quantity of interest, and I name it 4. Understand it, it is divergence of grad phi, because grad phi is a vector. So here in the definition of divergence, we replace V by del phi. So we have to instead of Vx, Vy, Vz, write the corresponding components of grad phi, which are just dou by dou x, dou by dou y, and dou by dou x of phi, dou by dou x of phi, dou by dou y of phi, and dou by dou z of phi. So divergence of gradient of phi is dou by dou x of dou phi by dou x, dou by dou y, dou phi by dou y plus dou by dou z, dou phi by dou z, which is just this first term is simply the second order partial derivative of phi with x. Second term is the second order partial derivative of phi with y, and third term is second order partial derivative of phi with z. Now this quantity has a name. It is called LAPLACIAN of phi. LAPLACIAN of phi. Right. So these quantities you need to remember. We will do an example. Let me write an example. We'll solve this example together. It says, suppose that the temperature T at the point XYZ is given by the equation T equal x square minus y square plus xyz plus 273. Then the problem says, in which direction is the temperature increasing most rapidly at -1, 2, 3, and at what rate? Understand the question. Let me check it. Suppose that the temperature T at the point xyz is given by the equation T is equal to x square minus y square plus xyz plus 273. In which direction is the temperature increasing most rapidly at -1, 2, 3, and what rate? So let us move to the solution. So as you can see from the question, we are given a scalar field. Temperature is a scalar field, which is expressed by this equation. And we are asked to find at a particular point at what rate it is increasing and in which direction it is increasing most rapidly, right? So first here we find the gradient of phi. So here gradient of, instead of phi we have t is 2x plus y z I cap plus minus 2y plus xz j cap plus xy k cap. This is gradphi. 2x plus yz I cap plus minus 2y plus xz j cap plus xy k cap. You chuck it. This is simply what? It is dou t by dou x. And this is dou t by dou y. And this thing is dou t by dou z. So when you do that, evaluate these partial derivatives, you will get gradient of t as this vector. And at, I have to specify the point now, given point in question is minus 2, 1, 3. So at minus 1 to 3, which is a given point, we put the values of x, y, z, x as minus 2, x as minus 1, y as 2, and z as 3. When we do that, at point minus 1 to 3, gradient of t will turn out to be 4i cap minus 7j cap minus 2k cap. So check it at home. Check it at home. Put the values. So we have found the gradient of t at the given point, which is 4i cap minus 7j cap minus 2k cap. And we know the increase in temperature is fastest in the direction of this vector. We have already discussed when we gave the geometrical interpretation of the gradient. So from that, you know the increase in temperature is fastest in the direction of this vector, that is del P. So first part of the problem we have done. Problem was asking us to find in which direction is the temperature increasing most rapidly at this point. So we solved Delphi at the point. So the increase in temperature is fastest in the direction of this vector. Now we have to find the rate of increase. The rate of increase is just the directional derivative dou t by dou s, which is the magnitude of this vector. And when you find the magnitude, it is just 16 plus 49 plus 4 in the square root, so which is under root 69. This is the rate of increase. You know just how we find the magnitude of a vector. If I have vector axi cap plus ayj cap plus azk cap, then the magnitude of this vector is just square root of x component square plus y component square plus z component square, right? So magnitude of this vector gradient of temperature, x component square is 4 square, which is 16, then minus 7 square is 49, then minus 2 square is 4. When you add up, it is 50. The 49 plus 4 is 53, and 53 plus 16 is 69. So this is the solution of this problem. I hope you got it. Now I will give you some homework, some simple homework. Homework. The question goes like this. Compute the divergence and curl of each of the following vector fields. Compute the divergence and curl of each of the following vector fields. So vector fields are given like this. First I have R equal xi cap plus yj cap plus zk cap. Then second is R equal xi cap plus yj cap. Third is V equal zi cap plus yj cap plus xk cap, zi cap plus yj cap plus xk cap. Then D is V equal yi cap plus zj cap plus xk cap, yi cap plus zg cap plus xk cap. E is V equal x square I cap plus y square j cap plus z square k cap, x square I cap plus y square j cap plus z square k cap. Then another part of the problem, f v equal x square y I cap, we write it neatly, x square y I cap plus y square x j cap plus xy z k cap. This is your homework. This is all for today. Do your homework. Make a notebook of all these video lectures that will be helpful for you. Don't waste your time. And don't forget to like, share, and subscribe my channel. Can give comment in the comment box. Thank you. God bless you. Assalamu alaikum.